So let me tell you about our next guest. It's Kelsey Hightower. Do you remember Puppet? I'm sure many of you have used that in the past, and that was really my first introduction to his work. And then since then, he's been a key figure behind containerization and distributed computing. He was an early team member of CoreOS, which is a fantastic operating system if you got your hands on that, before his career really took off around Kubernetes. Now, in 2015, he co-founded KubeCon. And if you've managed Kubernetes in production, you've no doubt read his book that he wrote. It's called Kubernetes Up and Running. In late 2015, he joined the ranks of Google, where he did a speed run through to Distinguished Engineer before announcing in 2023 that it was the last job that he'll ever have. I've heard him say that he's retired, not tied. So obviously still busy in the tech community. I'm super excited because he's actually here right now live with me. He's joining us here to discuss engineering at scale, what separates leaders from laggards. Welcome to Monster Scale, Kelsey.
Happy to be here.
Yeah, fantastic. So I guess we'll get straight into the questions. If we could look at my first question, that would be awesome. So Kelsey, given everything that you've seen from Puppet to CoreOS to Kubernetes at Google, when you think about engineering at scale, what's the biggest misconception you see teams have when they think that they're ready to scale?
Look, I've been always impressed with the engineering effort that goes into the underlying implementations. Just when we think we hit the dead end mark, it seems like memory or CPU gets faster, and then the software tends to catch up to take advantage of all those things. But I think the biggest misconception is that you gotta fail before you scale.
Right.
I think a lot of people go and see a conference talk. I'm probably guilty of this myself. Yeah. And you just go and try to do scale things before you even have any experience with the thing you're actually doing. And when I mean fail by scale, like the days at Puppet Labs, lots of people wrote shell scripts with bad error handling, things go awry when they're not in perfect conditions, and then they moved on to configuration management. And the people who made that journey were able to take advantage of all the things. Those that just started with Puppet, I don't think they had the background context and framework to understand the trade-offs that they were making to do so. So I think the best thing you can do is, before you try to go and over-optimize for a problem you may or may not have, you might want to know, how bad are you? Where's the metrics to prove that you need a more scalable solution? And I think that's the big trade-off here.
Yeah, right. So is that a little bit of Yagni, you ain't gonna need it early on and sort of just like let it burn kind of thing? Is that what you're suggesting? And then go for it, take those lessons and apply it to your scaling journey.
Have a reason.
Yeah.
Have a reason why you're doing that.
Yeah.
Also, I think for most people, sometimes you can do nothing and just wait for the scaling thing to be the default option. Yeah. But one place where I think people get stuck is they don't have the ability to move. Yeah. Right? Like maybe you're using something that now has an open source thing that is built for scale, but you have no way of migrating to it. Maybe you got stuck with some extension that doesn't port over well. And I think a lot of people get trapped. So when you say laggard, that means you fall behind for some reason, and sometimes it's unintentional. You're just using some particular implementation where you can't migrate to the thing, even if it offers a 10x performance boost.
Yeah, right. So do you think, in talking about people that get left behind, that's what we're really interested in, because I think sometimes people are sort of thinking that future state, and maybe optimizing for something that hasn't even happened yet, right? So maybe making the wrong tool choices right up front. Like have you got any experience around that in terms of tool choices, for example?
It's going to change. If you're watching this and you're not sure whether you're on the right stack or not, I promise you, in enough time, it's going to change. And when it does change, can you take advantage of it? So what does that mean? Make the best choice you can for now. Right, you can spend all week, all year trying to optimize for the best thing. The truth is, it may not be the best thing 10 years from now. And so let's say you pick a database technology. You're going to go all in on that thing, learn the best practices, but you can just put a little footnote in that design doc. Here's how it would change. Export the schema. This is our data set. Our data set is intentional. And if we need to move a subset of it to a different database, we can do that. But we don't need to do it now. Just that one step of admitting that it will change and having an estimate of the switching cost.
Yeah.
If you just do that step, so when the new thing does show up, you're not going to battle yourself with sunk cost fallacy.
Yeah.
You're going to understand that, yes, this part of the schema, we knew one day that it was going to be subject to change, and we're ready for that. And I think that's the big delta that people are missing. It's going to change.
Yeah, that's a really good point. I think just accepting that things will change. If you looked at like a 10-year journey of a startup, for example, whatever tech they went out with their first 100 users is probably going to be radically different to where they are. Like, or if they survive for 10 years, that's amazing, right? So,
And don't let that fact paralyze you.
Yeah.
I know some people will look at that and say, oh, I should do nothing. It's like, no. Take full advantage of the thing you have in front of you and be willing to know that it's going to change, and change isn't a failure. Right?
Yeah.
Just because you've been using your database for only 10 years,
Yeah.
there's nothing wrong with that. And sometimes it's not going to be a full replacement. Sometimes a subset will move somewhere else. Like I remember when caches came out,
Yeah.
right? You move a subset of data, not the whole thing. So I would just say welcome change and just plan for it ahead of time. Don't over-optimize,
Yeah.
but just know it's going to happen and be ready.
that's probably a pretty common scenario too when we're talking about databases. You're good for the first, few million rows, let's say, and you get to the 100 million rows, but it's normally like one table that's kind of driving that growth, isn't it? And that's I think what you're saying is you take like a small section of whatever you're trying to optimize for scale, you take that out and maybe swap it out with a cache or whatever you're trying to do.
And that's what we consider a good problem to have.
Yeah.
Where we have so many paying customers, actual revenue, and you're getting to a point where you know that you have to make a change to increase the number of customers you can have. The thing we don't want to do is have 0 customers and do all of this over-engineering for a problem you don't have. So
Yeah.
I think getting to the point where you have a clear problem, we've hit the limit of this particular technology, hopefully that translates that we are super successful, that we're hitting the limits of our current implementation. You have all the reason to move and probably the motivation to see it through.
Yeah, right. That gets me into one of my canned questions I had. Like, when you're designing a system architecture, how do you actually balance the need for scalability with that desire to sort of move quickly? Because you're trying to iterate, you're trying to get stuff out in front of customers. So how do you make that how do you achieve that balance?
Yeah, when I was at Google, one thing we used to do, the technical whiteboard sessions. This is the part that doesn't make it into the conference talks. You get on that whiteboard and you draw a line and you add time. Today we're here and our platform allows us to do these things. Is that good or bad? And then you draw time. Where do we want to be in 2 years?
Yeah.
What do we want to be able to do in 2 years? And usually that's driven by the development teams and the things that they would like to build, features that your customers have been asking for. You can't do all of those things at once. And if you just zoom out and you draw time, you can put little milestones and checkpoints. We're going to add this set of features in 6 months, this set of features in a year, and those things may move around based on actual need. And so then when you're doing that design, you have a place to put the stuff you can't do right now. You put it further out in time. When a new library shows up, a new project shows up that offers all the things, if you look at your now timeline, AKA roadmap, you'll see the match. So if I can just download and install a new thing and get 2 years into the future, it just makes sense. So I think we all have enough experience at this point that if you just add a timeline to your design, it allows you to do amazing things without feeling guilty that you can't ship it all on day one.
Yeah, that's interesting because I always found that sometimes it's the business that's driving that timeline, and you're locked in, you're doing your development, you're quite squirreled down, and maybe don't have that sort of wider view of like where things are heading and what features you need on the roadmap. You probably know the roadmap, of course, but I think this implies that you have pretty good a pretty good understanding of future state, but also a really good understanding of the system that you're running on, right? In terms of observability and metrics, like understanding like how your system's scaling. Do you have any sort of experience you can share on that?
In addition to those technical aspects, right? Here's our current performance, here's our current utilization, here's our current cost. Don't forget imagination. When you get the invention of like commercial flights, we also invented another thing called vacation. You can go to another country for 3 days and come back home. That wasn't possible when it's a 9-month journey by sea. You live there now. You're not going to spend 18 months just to spend 3 days in one place, but you have to have this imagination of the vacation. What if people can just visit for a short amount of time? That means you got to reduce travel from 9 months to 9 hours. And I think when we think about our roadmaps from a technical perspective, even when we talk about this business tug of war, sometimes on the technical side, you can give the business new ideas. We've gotten latency so low that we can do a multiplayer video game where people can play at the same time. That was unimaginable before until we got faster networks and the type of infrastructure here. So I would say, don't forget about creativity. Like, we're scientists at heart. We will do all the metrics. We will have the thesis. We will back it up with data. But there are things that we don't know yet. And that's where I think creativity comes into play.
Yeah, right. We were talking before the show. I'm a big fan of CoreOS. And I guess we could say that predates Kubernetes, right?
It does.
So you saw a lot of that change, going. Maybe you could talk about your team, what you were sharing with me before about, and I guess I'm not pointing out anyone in your team, but what's separating sort of leaders from laggards? Is there any sort of like resistance to change? Something impending. Like you saw it, right? You thought Kubernetes was the way to go, even though you had a really strong user base with CoreOS. So
I'm gonna give a little defense to the laggards. Sometimes you're working on something so critical that you cannot make changes because that can result in danger. And so you have to be default defensive posture. Yeah. And I get why you want to delay until things mature, because we've seen a lot of hype cycles that didn't pan out. And so I think those people are trying to do the best they can by being very mature. Our job sometimes is the freedom we have as people who can just work into the future. We can experiment, we can break things, we can try things before they're stable. And so if we do a good job, our goal is to get those things as stable as possible so that the laggards can just upgrade. Right? And so I think a big part of this, like at CoreOS, was we had this vision. We were going to create Google's infrastructure for everyone else. A lot of people read the Borg papers, implemented things from the Borg paper, and made them available. And we had this nice roadmap. We had Rocket Container Manager. We had the Fleet database for synchronizing workloads across multiple machines. We were all set. Our roadmap was clear. And out of nowhere, this thing called Kubernetes shows up. And one thing that I realized is that we didn't know what we didn't know. The Google team had decades of experience building distributed systems. They also failed a few times, right? There was a couple of white papers, the Mesos paper, the Borglet, the Kubelet. And I think what the Mesos team did is they ran that experiment to its logical conclusion, and Docker and the rest of the environment made way for this thing called Kubernetes. We couldn't see it because we didn't live that history. And at CoreOS, we had to make a decision that even though we were leading, overnight, it feels like you become the laggard.
Yeah.
Right? And so being able to be humble enough to know when that happens to you and make the decision to switch trains because you're no longer headed in the right direction, that was key for us at Kubernetes to realize that maybe we didn't have the perfect roadmap, so we switched.
Yeah, interesting. Comes to, what's that saying, opinion strongly held, but what is it, loosely coupled or something like that?
Yeah, they need to be, or the industry will decide for you.
Yeah. So I think I think what you're saying is it's okay to be a bit of a lagger. Like, it's almost the role of a senior engineer to be a bit defensive, because they've been through all the hype cycles. Oh yeah, well this is just another X.
We need everybody. You know how this works, folks. We need the people that make this stuff mature. We need the people that are challenging that maturity, moving forward. And as a community, that's where we create that ecosystem.
Yeah.
We need that loop. So sometimes you're going to find yourself on either side of the spectrum. Just know we need you all.
Right. I've certainly worked in my fair share of dev environments, I guess, where things are over-engineered. There's that tendency. And I've never worked at Google, so I don't know what happens at Google. Be really interested to hear, like, what are some of the practical ways that, even in Google, that you avoid over-engineering solutions when you're talking about scale?
I don't know if people avoid over-engineering.
Yeah.
Because over-engineering to you may be simple to someone else. Yeah. I think also when Google Cloud came to be, it was the first time that Google's infrastructure was exposed to the outside world. People use things like Gmail and Maps, but you didn't really have to interact with things like gRPC or Stubby, what is called internally, or Google 3. And so once cloud comes out, it changes. Parts of Google's infrastructure becomes your infrastructure. So the protocols need to align. So when people saw things like gRPC, if you looked at it like, that is literally over-engineering. Why do I need to pre-compile the bindings for particular languages? Who needs to support every language under the sun? This is over-engineering. That's the way people perceived it, because Google was literally engineering for Google scale needs. And I think it's one of those things where when cloud came out, the customer base said, no, we use REST. And so Google then had to make sure that our solution scaled down. And so I think sometimes when things are built for big things, I had a customer one time show up to a meeting and he said, hey, we want BigQuery on-prem. I was like, you do?
Really?
Okay, so how much money do you have? And it's one of these companies that has lots of capital, so it was no problem for them. I was like, all right, it would be the equivalent of going to the airport and looking out of the window and seeing a nice 747, brand new one. And you go to the ticket counter and say, hey, I would like the plane. And one day they say, you know what, you can have it. You can have it right now, it's all yours. You don't have a pilot's license. You don't even know how to fuel it. And where are you going to park it? Are you going to drive it down your subdivision, decapitating the roofs of your neighbor's house? So some things aren't meant for everyone. And I think the one way to do that is just make sure you understand who the target audience is. You really do need to know how they work, what tools they use, and is it even compatible? So one way to avoid over-engineering is to engineer for the target audience. And sometimes they don't need what you're selling.
Yeah, and I think, you know, I won't use that analogy, but it's a great one, but, you know, with the plane. But there's a lot of presentations at, you know, today and tomorrow and also at P99 conference where you hear from big name companies. And a lot of the times the scaling strategy is quite simple, you know what I mean? Like it looks pretty simple, it's just done at scale. There's a lot that can go wrong.
You know what, as a speaker, I know this is an interactive platform. One thing you can ask every speaker that is showing you what they're currently doing, ask them what they were doing before. It tends to be the trick that I use to really resolve the design gap. You've landed here, but where did you start and what did it take to get there? And I think when you hear the answer from a lot of the speakers you'll see today, that's going to be that missing piece of why should I even do this? What were you doing before? And then have them fill in that gray area.
Yeah. Speaking of questions, if you've got questions, make sure you ask in chat. I've got some coming here. There's a question that is, what are some common mistakes that laggard, it's a funny term, let's come up with a better name. What, you know, the people that are lagging behind, I guess, what are some of the common mistakes that they make when they're scaling their engineering operations, and how can those be avoided?
Literally not even understanding what already works. A lot of times I see people wanting to rip and replace the whole thing, and they throw out the good parts, or they don't realize why the challenging parts exist. So typically it's just like the classic way of thinking about automation. Write down the manual process first, clean up the unnecessary parts, even in the manual mode, then you automate. And so when it comes to scalability, it's the same thing. Some people say, my database doesn't scale. Well, your schema is not where it needs to be. You have data in the wrong places. You may need to redesign your schema or think about your data needs. Well, I think a lot of people, especially in the classic database arena, you know, we all been taught to denormalize our data, use joins to put it back together. That is not always the most optimal thing. And you have to realize, I'm here for this reason, and maybe you were dogmatic about the original decision. You need to be willing to break that. So if you don't, here's the mistake you're gonna make. You're gonna buy a bigger VM.
Yeah.
You're gonna put a terabyte of memory on it so you can continue doing the thing you're doing. And that is not the right way necessarily to think about scale. Sometimes it makes sense just to take a small bit of that data and create a materialized view and a hyper-optimized thing. We used to call that caching. But these are like fundamental ways of doing the right thing by understanding what you currently have and then just taking that surgical approach to it.
Yeah, there's probably some, you know, anti-patterns there, I guess, like code smells when you're upsizing your RDS cluster for the third time because, you know, your business is booming. It's probably a good combat indicator to maybe look at how you're using the database. Like, when was the last time you analyzed some queries for performance, you know, checked all the indexes, all that sort of stuff?
I think there's another important one there because as someone who's worked at vendors over time, one question that most customers show up with is, what are the best practices? Not necessarily the best practices for me. I just want to know, what is everyone else doing? And they want to attempt to copy and paste that. And I think that might be another anti-pattern in the mix where you only care about what everyone else is doing, and you don't bring the necessary context for me to give you a clean recommendation.
Yeah, it could. I mean, the answer could be quite obvious if you put down the best practice handbook and just say what sucks.
Or stop doing that.
Yeah, exactly. And I think you mentioned automation as well. I've seen people do a lot of optimizing for performance in production when perhaps they needed to just optimize their CI/CD tool chain because that absolutely sucked and they were wasting, it prevented their ability to iterate and get stuff into production, you know what I mean? So sometimes it's not even about, the production environment, it's about how quickly you can develop, how quickly you can iterate on the solution, which I've got a question there. What role do you think dev tooling plays in engineering leadership and how do you make sure that your devs, as a leader, have the right tools, with the least amount of complexity, the right tools for the job?
I was at a big enterprise and I was giving one of these presentations to the executive leadership team, and then they had the team leads there as well, including some of the people tasked with doing the most important work. And I was giving them or demoing them how I work, the tools I use to get the job done. And I remember with the tremble in his voice, they won't even allow us to install Python on our laptops to do what you're doing. And I thought about it for a moment. I was like, wow. When you make it hard for someone to do the very best work, like telling Picasso he can't use his favorite paintbrush to do his work, that then straps down the team. So the idea that everyone's going to work exactly the same way is false. You probably want people to be creative in their own sense. So I think what any engineering leader can do when it comes to dev tooling, figure out what people actually need and want to use, and then promote them sharing. So I'm going to be very concrete. We have these weekly stand-ups. We have these engineering offsites. Make time for people to show how they work. If you've ever watched someone do a really great live demo, you've seen that part where they pull up Vim, and they have a couple of extensions and plugins that you've never seen before. And you're like, what key combination is that? How is this person moving so fast? And a lot of times we don't get to see that nuance in action because we're typically showing people the final output. We're not really showing people the way we produce said output. And so if you go around the team, there's probably 6 or 7 different ways of working that makes people super productive. If I only knew what your setup looked like. And this is why I think a lot of engineers love to know, can I just see your setup? What computer are you using? What OS? What IDE? What extensions and plugins are you using? Because when you put those things all together, that's where productivity comes from. And it doesn't mean everyone's going to work the same way, but I think everyone should share just in case.
Yeah, I remember when pairing sort of took off. That was, that was great. Just, being able to mentor others, I think that probably is a sign, or, one of the ways that separates the leaders, that if you can pass on those skills and, keep the ladder down, make sure that the people know how to get to where you're at, the keyboard shortcuts that you're talking about, maybe your Vim setup, all that sort of stuff. I'm not sure what editor you use, by the way. But
if you wanted some inspiration, share the nuance. I think a lot of people I meet for the first time, especially engineers, they think that the things that they do are too small and insignificant. But I promise you, if you're willing to share those, like I want to see your dot files because I don't know what flags are available to me, and put comments in there. And you'll be surprised at how many people get inspired by your workflow.
Yeah, any other little tips in there from just that you've seen, especially at Google? I think people are always interested in how teams operate in there.
Well, Google invested a lot in a thing called Google 3. The engineering culture was basically solidified in this thing. Thinking about things like Stubby or gRPC, having a schema for all interactions between clients and servers, having a mono repo, not that that's the best design ever, but they treated that mono repo like a product. Static analysis, deployment tools. There was a point where you can just go with your browser, pop into a particular piece of code base, and the IDE would pop up in context. And all the necessary things to contribute to that subset of the code base was just built into a clean default workflow. We called it Cedar. And so I would commit a change, and then people I never met before would start doing this review based on SLA. And so what Google really did a good job was serializing the engineering culture. And so what does that mean? When you have 10, 20,000 engineers, how do you make it easy for the next 1,000 that join? And I think you have to start serializing the things that actually work. Because I've seen a lot of companies come in, they issue the corporate laptop, and then you spend a week getting that thing set up for maximum productivity, only to find out that you're still missing a few parts when you start working.
Yeah, fantastic. I know we've only got probably like 60 seconds left, so I thought we might just finish on something about soft skills or balancing skills, because we've spoken a lot about technology and tooling. But in your opinion, how important is it for an engineering leader to have the deep technical expertise versus, say, good soft skills, the ability to manage teams, talk to the business?
Well, if you don't have those skills, someone else does, and they will dictate the work.
Yeah.
And I've learned to inspire folks. And so that's getting that documentation right where people want to use it. That's getting people on board even when they disagree. Anytime you come up with a great solution, your very next act is to prove it to everyone else. And there's a saying that I like, and I'll end here. There are some people that have good ideas, and there are some ideas that have people. And so when you can get your idea to outlive you, I think you've done it.
Yeah, fantastic. Well, Kelsey, as you've been quoted saying, good programmers copy, great programmers paste. Is that still true?
Yeah, we call it ChatGPT.
That's all we have time for today, Kelsey. It's been such a privilege to have you here in the studio and live talking to, it's like you're like royalty to me, so it's fantastic. I'm sure you're going to be hanging around and chat for a while to answer some more questions that people might have, but thank you very much, really appreciate